This section is about sketching quadratics. It's an essential skill at A level, and you'll go on to sketch numerous functions in the future, but for now we're looking at quadratics. You should know from GCSE what a general shape of quadratic is. We're looking at either a U shape or an N shape, and this shape has a specific name which you may have met before, and that is a parabola. The quadratic has a few properties. It has a changing gradient, so it shouldn't look like a test tube with lines coming straight down, and it shouldn't have any sharp corners. We have a min or a max point, depending on whether it's a U or an N, and it's symmetrical about that minimum or maximum point. In order to sketch our quadratics, there's a few key bits of information that will help us do that. First being the y-intercept, so we know where we should be hitting the y-axis. Also the x-intercept, so we know where we're hitting the x-axis. And the location of that min-max point, so we know where to aim our graph. In order to find the y-intercept and x-intercept, you must remember the equations of these axes. The y-axis has the equation x equals 0, so if we're trying to find the y-axis, we must set x equal to 0, and the x-axis has the equation y equals 0. So again, if we're trying to find those x-intercepts, we would set y equal to 0. To find the turning point, that maximum or minimum point, we use something we've just recently covered, and that's completing the square. So if we have this quadratic here, and we want to know the location of the turning point, we would simply complete the square on it. So we halve that middle term. 3 squared would be 9, so adjusting that to get 8 give us minus 1. So to find the minimum for this quadratic, when is this at its least? Well, it's at its least when this bracket gives 0. That would be when x is minus 1, x is minus 3 rather. And when x was minus 3, we would get negative 1 out of it. So the location of our turning point would be the coordinate minus 3, minus 1. So that's how we find our turning points. So if you just pause the video and just write down what the turning points would be for these 6 quadratics. For the bottom 2, you'll have to do the completing the square on your own. Right, now some full examples of how this works. So we're going to sketch the quadratic x squared plus x minus 6. So first of all, I'll start by completing the square. So half that middle term. And then a half squared would be a quarter, so we can subtract that off. And then subtract 6. In other words, we've got x plus a half squared minus 6 and a quarter, or 25 quarters. Therefore, this quadratic has a minimum point at minus a half, negative 25 over 4. We can see from the equation that our y-intercept is going to be at 0 minus 6. Substituting x equals 0 in gives us minus 6. To get our x-intercepts, in this case, we can actually just factorize. The quadratic we've got factorizes into x plus 3, x minus 2. So when this is 0, we've got x equals minus 3. And we've got x equals 2. So we've got all our information now to sketch it. We've got our y-intercept, we've got our x-intercepts, and we've got our minimum point. Now when we're sketching, we shouldn't just put these values on. We shouldn't try to fit a scale onto here and then force our quadratic to go through that. The best thing is to just get the general position right. This is only a sketch, and put these values on afterwards. So we know our minimum is at minus a half minus 25/4, so somewhere down here. So that's where our minimum needs to be. It needs to go through the y-intercepts of minus 6 somewhere down here, and the x-intercepts need to be minus 3 over here, and then 2 over here. So something like that would do. Is our y-intercept minus 6, x-intercept minus 3, x-intercept of 2, and our turning point of minus a half minus 25/4. Okay, next one. Same process. I'm going to start by completing the square. Half that middle term. 3 squared is 9. We have to subtract 2 to take it back to 7. Y-intercept is just at 7. Coordinate 0, 7. For the x-intercept, we can actually use the complete the square form. We're looking at when is this equal to 0, so we need to solve this equation. So we'll do this in full. We can add 2 to both sides. Square root. Remember, we get plus or minus. Root 2, and then add the 3. So our x-intercepts are at 3 plus or minus root 2. So we can now sketch it. Just our minimum, forgot to say, was at 3 minus 2. So our minimum is over here somewhere, 3, negative 2. Our y-intercept is up here at 7. It's not the best sketch. Just my laptop not keeping up. Here is 3 plus root 2. This would be 3 minus root 2. 7, and then our minimum. 3 minus 2. Right, one more. Sketching the quadratic minus x squared plus 6x minus 5. Start by completing the square. So first of all, factorize that minus out. Now complete the square. Half that middle term. 3 squared is 9. That would be negative 9. So we have to add 4. Take it back up to the minus 5. So this now is giving us a maximum. Because this is a negative x squared, we're going to have an upside down quadratic, giving us a maximum point then at 3, 4. Y-intercept, when x is 0, we just get minus 5. For the x-intercepts, this quadratic actually factorizes into x minus 5, x minus 1, negative in front. So our 2x values are 5 and 1. Okay, so we've got a maximum at 3, 4, y-intercept at minus 5. And then our x-intercepts are at 1. And 5. Obviously not very accurate, but it is just a sketch. We are just indicating where these points are. It does not need to be an accurate plot of the quadratic. Now, slightly different. Just zoom into this one. No. Same process here. X squared plus 6x plus 10. This one's going to come out slightly differently. I'll start by completing the square. 3 squared is 9. Adding 1 will give us a 10. Let's give just a minimum. Minus 3, minus 1. We have our y-intercept. At 0, 10. And if we were looking for our x-intercepts, we'll be solving this. To solve this, we would have to subtract 1 and then square root. As you should know, you cannot square root a negative number. So this has no solution. That doesn't mean we can't sketch it, it just means it has no x-intercepts. It does not cut the x-axis. We have a minimum at minus 3, minus 1. Sorry, minus 3 plus 1. So up here, minimum there, y-intercept of 10. So we have this shape. So we can still sketch a quadratic even if there's no x-intercepts. If you can recognize from the start that there isn't going to be one, you can save yourself a lot of time. So don't just follow the process every time. Think about what you need to be doing, and you can save yourself some effort. Right, you can use the same process now to sketch the next two. X squared minus 6x plus 9, 2x squared plus 6x minus 3. Just be careful with completing the square on that one. And then have a go at question 1 and exercise 2f. Final thing, just a bit of problem solving. Working backwards. If we know the curve looks like this, we know the x-intercepts and the y-intercepts, we can also work out the equation of the curve from those bits of information. Starting with the 2x intercepts, we know minus 1 has to be an x-intercept. So one of the brackets must be an x plus 1. For 2 to be an x-intercept, the other bracket must be a minus 2. So this curve definitely goes through these 2 points, but does it go through negative 6? Well, if we expanded this, we'd get x squared minus x minus 2. This curve has a y-intercept of minus 2, not minus 6. To change this into a minus 6, we would have to multiply it by 3. Multiply the whole thing by 3, which means our equation for this curve must just be what we had before, but multiplied by 3. There are some similar problems to that in question 2 of this exercise. So go ahead and